My name is Addison Sears Collins, and this is Project 8 for Johns Hopkins University, Software Development for Real-Time Embedded Systems. That's 605.715. The title of this project is Quadcopter Downloading IMU from Raspberry Pi to Host via Wi-Fi. So we're going to use the IMU connected to the Arduino, mounted on the quadcopter and hopefully flying, capture Roll+Pitch+Yaw data, send via serial over USB to the Raspberry Pi, send via Wi-Fi from Raspberry Pi to the host, and display on the host computer. And then on the Arduino, use FreeRTOS for testing this project to learn about and get experience with an RTOS. So those are the requirements. And first, let's take a look at the hardware setup for this. So I'm going to pan out here. You can see the full quadcopter here, all of the peripherals and our sensors in the center here on the main platform. I'm going to go through each one piece by piece. So here on the very top, I have my breadboard. I have my Adafruit BN0055 9-axis absolute orientation sensor. That's the IMU. This is reading all of the data. And we have wires that are connected into the top of the breadboard, which are connecting this IMU down bottom to the bottom here, this brown casing here, which is the actual Arduino. It's in it. Arduino is inside there. It's a protective case right here. And here's the cord here, which extends from the, you can see it's extending from the Arduino and it's connecting into the Raspberry Pi. So this is the USB. This is how the serial data is going to be transferred USB from the Arduino, this blue cord, follow it, and it's going to go all the way around the quadcopter, comes back up in here, and then back in the base into our Raspberry Pi, which is this black case right here. That's the Raspberry Pi. Here's the USB connected to the Arduino. Okay, and so this is one of the requirements. It says send via serial over USB to the Raspberry Pi. So that's how that data is going to be sent. So capturing the Roll+Pitch+Yaw data up here by the sensor, which gets fed down into the Arduino, which just gets fed via USB serial communication down into the Raspberry Pi, which is this black case below. You can see that there. And then powering all this, you can see it's on right now, is this battery pack, which is plugged in to the back of the Raspberry Pi. That's where it gets its power from. It's powering the whole system. And I'm going to zoom out again so you can see the whole hardware setup. So, as you can see here, another of the requirements is we are going to have a host computer, because the Raspberry Pi, this black case right here, needs to send the data via Wi-Fi to the host computer. We need to display the data on our host computer. And so the host computer is this computer right here, my just regular Hewlett-Packard Omen laptop, and I'm going to be displaying the data on this computer here, which is my host. And you can see that the host computer is not connected to the Raspberry Pi physically, but they are connected via Wi-Fi. In fact, if we go over here, click in, I'm going to zoom in here. Probably see my reflection in the screen here. And I am going to click on VNC Viewer, this icon right here, to open up the Raspberry Pi. And so this is how I connect to the Raspberry Pi on my host computer. You can see we're now inside the Raspberry Pi computer right here. That's the Raspberry Pi. Okay, and it's on my host computer. We're live. And we have our Raspberry Pi over here in the Quadcopter. So all of this data that's going to be fed into from the sensor into the Arduino and then to the Raspberry Pi is going to be transmitted via Wi-Fi to our host computer. So that's the hardware setup. Now I'm going to walk through the software setup to show you a little bit more of the detail behind how I use FreeRTOS for tasks in this project, and a little bit about how I was able to capture the IMU data and how the algorithm works. So let's go to that now. Let's go to the host computer and let's take a look at that now. I am in VNC Viewer right now. You can see that right at the top. So I'm inside my Raspberry Pi. I have opened up Arduino and I am in the software for this project, Project 8. So let's walk through the code step by step just so you can see what's going on here before we actually fly the quadcopter and collect the roll, pitch, and yaw data. So here at the top, I have the libraries that are included in the software. You can see that I'm using the FreeRTOS library for Arduino, as well as the two sensor libraries here, BNO055 and the Unified Sensor libraries. This helps to produce that roll, pitch, yaw data. And I'm using FreeRTOS, and you'll see how that factors in a little bit later here. So first step is we need to define two tasks, and the tasks that I use in this project are going to be two things at once. So it's multitasking here. So the first task is to blink the built-in LED on the Arduino board. So this task is responsible for that. So here's the function prototype for the task blink, which is the first task. And then the second task is the workhorse task, which is going to be actually capturing the roll, pitch, yaw data from the Adafruit BNO055 sensor. So it's two tasks, blinking an LED and then capturing the roll, pitch, and yaw data. So that's the RTOS tasks here. I'm going to keep going down below. So here's our first tasks here. This is the blink LED task. This is task 1. And this task turns on the built-in LED for 1 second, then it turns it off for 1 second, and it keeps doing that over and over again. It's probably the most basic program that you have in Arduino. It's a very popular program that's used when you're just getting Arduino startup. So you can see here the LED goes on, LED goes off, and this is the first task. All right, and now I'm going to keep scrolling down here. Here is our second task. This is the IMU task, IMU read task. Here's where we capture the roll, pitch, and yaw data. And this is where it's going to print out to the serial monitor the yaw, pitch, roll data. And the library is hard at work in the background. Some more methods that are used by the tasks. These are here. Calibration status, so sensor calibration status, and displaying some other information on the sensor status. Here's our setup function, initialize serial communication at 9600 bits per second. Printing out some text to the serial monitor, getting everything set up, sensors. And then here is where we set up the two tasks to run independently. So have the blink task, which is given the 1 priority, with 0 being the lowest, 3 being the highest. So I gave the blink LED task 1 priority, and the IMU read task a 2 priority. So the IMU read, capturing that roll, pitch, yaw data, has a higher priority than actually blinking the built-in LED. And since all of the tasks, all of the work being done in this program is actually done by tasks and controlled by the task scheduler, we don't do anything inside this void loop, which normally you have a bunch of code here in a normal Arduino program, but everything's done in tasks, so we can just leave the normal Arduino loop here empty. So that is the software, and now I'm going to actually run it. I want you to show you actually where the built-in LED is blinking, and then I'm also going to show you the Roll+Pitch+Yaw data that's going to be printed to the serial monitor here in the Arduino. So let's go to that now. All right, now I'm going to save the program. Let's press compile. It's going to take a moment here to compile. Looks like we got a message here, or done compiling. Let's now upload this sketch to the Arduino. Okay. It's done uploading. So if we click this serial, we should start to see the Roll+Pitch+Yaw data being printed out. Okay, and you can see the Roll+Pitch+Yaw data being printed out here to the serial monitor. This is task 2. And none of these values are changing, you can see, because my quadcopter is not yet flying. So it just keeps printing out. Let's close that. And now let's go to the Arduino board and let's see if the built-in LED is blinking. That is task 1 for the RTOS system. The LED is in flat blinking here on the Arduino. You can see it blinking here. I'm going to zoom in so you can see it a little bit better. So this is task 1 again. So we know everything's working correctly because our Roll+Pitch+Yaw data is being captured on the serial monitor, and we also see the built-in LED blinking. So our 2 tasks are working. Okay, the quadcopter is all set up, software is all set up, and now we are ready to fly the quadcopter so we can capture the Roll+Pitch+Yaw data in a real flight. So let's take this quadcopter outside. I'm going to plug it in right here using the LiPo battery, and I'm going to take my host computer outside as well, and we are going to capture and display the Roll+Pitch+Yaw data. So let's get to it.